So welcome to day 2 of Droidcon Turin. And please put your hands together for the bearer of good design patterns, Nick Butcher.
Buongiorno. That's all the Italian I know. So, can we turn the music down? Thanks. Hi. Well, thank you. Firstly, thank you very much for having me. It's exciting to be here. It's a real hardship for me to have to come to Italy to speak to you guys and eat some amazing food and meet some amazing developers. So thank you so much for inviting me here today. As Sebastiano kindly introduced me, my name is Nick Butcher. I work at Google in a couple of roles, really. I'm both a designer and a developer, which is somewhat rare combination. I work on projects like, hopefully you guys know this is Google's I/O application, or I/O shared as we call it. So I've worked on this app for a few years now, but last year I actually worked solely on the design, which was a kind of a new thing for me. So I've worked on projects where I was just a designer, like creating mocks and motion prototypes and red lines and other designery things like that. I've worked on code-only projects, so I was part of the original team that made this app. This is the Android device manager where you find and locate and lock your phone and so on. That started off, fun fact, as a 20% project. Google has this 20% time thing where you can work on something slightly different, and I worked on the team that built this. So following proper Google big company coding standards and so on. And I've worked on things in between. So this is a sample app which I build, which I design and build. So I kind of sole designer and developer, working as a single-person team, I guess. So what I'm trying to say is I kind of have some experience from working as a designer and working as a developer. And in doing that, I've learned a few things about what the differences between those two mindsets, and some practical tips for how you can improve your development work by understanding some design, and the other way around also. So today I would like to share some of those tips from my experience with you, and really say that just like performance and enums, that design matters. So design, I think, in recent years has had a big change. It's gone from being kind of a veneer, like a surface level, make it look pretty stage. 10 years ago, 5 years ago, that's very much how design was regarded. Whereas now, design is much more involved in the start of the process. What does the product do? And it's kind of really integral to making any products really out there. Some stats, like these are some stats from a VC in San Francisco saying that basically companies are considering design as a differentiator. This is how they're going to make their products stand out. This is how they're going to grow, how they're going to get people to kind of really enjoy and share their love of your products. In the Play Store, there's over 1 million apps, in the Play Store. Like, how do you stand out? Like, design is becoming one of those differentiators. When there's 10 apps that do the same thing, I know I choose the one with the nicest looking logo, or the one with the best screenshots, or something that promises to me that it's going to work better through all levels of design. Also, if you want to get promoted on the store, be featured in the collections and so on, design is a huge factor in Google's process for doing that promotion. And lastly, who's seen something like this? Like, users are aware of this. This isn't just like something you do just to kind of, because Google says so. People are demanding this. People's expectations have raised since things like material design has come out, and people have used it throughout like the Google apps and some of the popular apps. People's expectations are so much higher now that you're being judged against that bar. So hopefully none of this is new to you. Hopefully you're sat in a room listening to a talk about designing. Hopefully you agree with me that design is important. But if you're not a designer, what can you do? Like, who in this room, by a show of hands, would consider themselves a designer? OK. That's awesome. Like, I think if I asked this question at Droidcon 2-3 years ago, that would have been even less. So that's cool that there are some people here. I very much like this quote by Steve Jobs, that design is not what it looks like and feels like. Design is how it works. I very, very much kind of agree with that. So given that definition, that the design is how an app works, like, who here makes decisions about how their app works? Like, hopefully all of you. Like, maybe you don't work with a designer at all. Maybe you're one man on your own. Maybe the design is kind of not fully like spec'd out. So, they have a state A and you have a state B, but how it gets in between, that's left up to you as a developer to implement. At the end of the day, I would argue that everyone in this room is making decisions about how the product works. So everyone in this room is making design decisions. Just think about that for a second. Like, you are designing. I think one of the most important things you could take away from this talk today, I'd like, is to take responsibility, to kind of, say, yes, I am making design decisions. And so, don't say, oh, I'm not a designer, therefore it's not my responsibility, or that's that team over there's responsibility. I'd say it's everyone's responsibility. Like, I think caring about the design is the first step. It's the thing that I think got me into like doing more design work from development because I cared. I wanted to make the best thing possible, and I kind of taking responsibility is the first step, I think. So now that I've scared you and said that you're all designers, the good news is that design skills are very much learnable. I think as developers, we sometimes see designers as like this mystical people from another planet, perhaps, who are born with an innate sense of taste and balance and so on, and understand things like kerning. That's not true. All design skills are learnable. Just like you weren't born understanding or knowing development skills, knowing coding or knowing good coding practices. You learn these things, you develop them, you practice them, you work damn hard at them. And the same is true of design skills. Now, there's lots of great resources out there. I just want to flag a few which I very much enjoyed and helped me. The first two are books which will give you a good introduction into design, like how designers think. And it'll make you never look at doors the same again. And the last one is a series of Medium articles, which I wanted to call out because it does this. It kind of breaks down some like visual design topics, which can seem really, really mysterious and obscure to developers, into a set of rules. Like, follow this process. These are the fundamental things you need to learn, and your kind of like design output will look better. Don't worry about capturing slides. I'll share links and presentations at the end, so you can have all that. So there's, just like learning coding techniques, there's tons and tons of resources out there to help you learn design techniques, and you very much can learn them. Don't feel like you can't. Everyone in this room can. I'm living proof of that. I had terrible design skills not long ago. But today, what I'd like to talk to you is something a little bit higher level. So rather than like specific skills, I want to talk to you more about the process and tools that designers use, and how we as developers can kind of use some of those to kind of improve our everyday work. And this has kind of got the umbrella term of design thinking. This has kind of come out of a bunch of amazing design studios like IDEO and so on, who have kind of like, a bit like how the software industry has like processes like Agile and so forth, which don't talk about the day-to-day practices, which are like more the process and the method. This is kind of the design equivalent, which is how you should consider and approach design problems. And in particular, one kind of, I guess, strand of design thinking I want to talk to you about is something called design sprints. So this is something that was developed at Google in our Google Ventures VC kind of arm. And basically, what we've done here is we've reduced our design process to make it as effective, as quick, and as repeatable as possible, and kind of documented it into this kind of step-by-step guide, which says, start this process here, do these steps, and you will come out with, a design product with this kind of rigorous methodology applied. We packaged it up, essentially. So a definition of a design sprint is, we say it's a five-phase framework for answering critical business questions through design, prototyping, and testing with users. So the key thing here is answering critical business questions. So what are you going to do a sprint on? This could be anything. This could be, we want to launch a new app to do X. This could be our product, people aren't discovering feature Y. How do we boost engagement? This could be, we want to do a material redesign. This is some kind of piece of work that needs to be thought through and planned and designed, essentially. That's the input to this process. We want to do a challenge. How do we do it? And to see how sprints are different, I think it's kind of useful to think about how we build software now. So right now, we start with an idea, we build it, we launch it, and then hopefully after launching it, you have some kind of quantitative metrics and so on. You learn something about what you built, and hopefully that feeds back into the next thing that you do, and you go around this circle. Now, kind of agile methodologies have helped us hugely here. Like, so we no longer do 2-year waterfall development where we spend 2 years going around this cycle. It's made the circle kind of smaller in a way, so we go around much quicker and do smaller pieces of work and learn quicker and course correct and so on. But there's still a few kind of potential problems with this traditional cycle. Firstly, you could spend a long time building and launching before you get to that learn phase. And if you invest that time and then launch, it's kind of hard to unlaunch it afterwards. Like if you do build something, you can't really, it's very, very difficult to roll something back, and you can like burn user trust that way. So what sprints aim to do is to kind of short-circuit that, to go from ideas to learning very, very, very quickly, to do that through prototyping and user testing. Sounds great, right? So how do you actually do it? So the sprint is made up of these 5 distinct stages: unpack, sketch, decide, prototype, test. I'll go into them all in a minute. We roughly tend to run this as a 5-day thing. So you come in literally on a Monday and do the unpack stage, and then Tuesday is sketching and so on. But you can compress this. In Google, we will quite often compress it down to 3 days. I've even done 1-day sprints, which are kind of intense, but also very fun. You can even flex some of these things depending on what you all, the scope of what you're trying to do or how much you know about the problem at the outset. You can maybe try and reduce this. The one key thing I'd say is don't drop the testing phase, and I'll get to that why in a second. So on the first day of a sprint, we have this thing we call unpack. So you'll do a bunch of presentations. So experts might present on the subject. So what I mean by expert is everyone in your business who knows about the problem you're trying to solve. So say you're going to launch a new feature in your product, you would try and get representatives from every part of the business who know about that problem into the same room. So that's not just design and not just engineering, but you have representatives from, I don't know, marketing or from your customer services, anyone who, might have a different perspective on the problem. And the idea is that by bringing everyone together and everyone presenting their kind of knowledge on the problem leads to this kind of common understanding. Also, having those right people in the room is super critical later on, because the ideas that someone in customer services might have, from day-to-day dealing with the pain points that people are having with your product is going to be very different to, an engineer who maybe sees the code and sees the corner cases more often, perhaps. In the unpack phase, we'll often present user research. So if we have existing research about stats on how people are using our product and so on, or if you don't have any research at all, sometimes we'll perform research. So we'll do some interviews. We'll invite users of our product or potential users of our product in and ask them a bunch of questions, essentially, to find out what they want, what they have problems with exactly. You might look at competitors' apps, see what they're doing, either direct competitors or kind of parallel competitors. But yeah, as I said, it's mostly this stage of the sprint is about getting everyone on the same page and getting everyone into the user's mindset of what you're trying to build. So over this day, there's a ton of presentations, there's a ton of interviews and asking people stuff. And throughout all this, what sprints say you should do is you should capture questions in a specific format. So it says you should sticky notes, just standard, regular post-it notes. You should write each question you have, one per post-it note, in a format which we call How Might We? So you start each question as How Might We, or just HMW, and then the question, one per sticky note. And the reason we do it that way is that How Might We frames it as an opportunity rather than a problem. So you don't just say, retention isn't working well. You'd say, how might we improve retention? Or it doesn't prescribe a solution as well. So it's not like you wouldn't write down, we should make the button blue. It's like, how might we make the button more noticeable? It doesn't constrain you into a solution. This framework really kind of helps. And at the end of the day, once everyone's presented and got onto the same page and generated tons and tons and tons and tons of these sticky notes, what we tend to do is take it in turns to put them up on the wall where everyone can see them. Pretty simple stuff. But what you'll find is as you put each one up and explain your way through it, clusters will start to emerge. People will start, everyone has been picking up on similar themes, and these common threads will start to emerge. And so you want to start clustering those into these little groups like this. Once you've done that and you have everything out and everything presented, the next step we do is then to vote on it. So by that, everyone gets stickers. It sounds very kind of consultancy, but honestly, it works. you get, say, maybe 3 stickers each, and you get to kind of go and put stickers on the ideas that you think show promise, the questions, the how might we's, which you think are the most interesting. Right, so after day 1 unpacking, you've got a bunch of questions and like promising themes about the challenge you're trying to solve. Stage 2 is sketching. So we do this thing called Crazy Eights, where you get a piece of A4 paper, regular paper, fold it in half, in half, in half, so you get 8 cells like this. And then we set a timer and say you have 8 minutes to sketch potential solutions to the problems which we identified. So the idea here is to have an emphasis on volume. It doesn't have to be the most well thought out idea. I mean, it's a small cell of paper and you're using a marker pen, so you can't get super detailed. But this gets lots and lots of ideas out there. We then stick those up on the wall again. But instead of talking through the idea, so when you did the sticky notes, you would talk through what the how might we was. Here we just hang these in silence, kind of on the wall, and then have another round of voting, so everyone goes around and votes. And the idea there is that it controls for salespeople. So some people are just really good at selling their ideas, right? Some people are more convincing, have louder voices. Some people are shy and don't like to sell themselves. By doing this kind of in silence, it sounds silly, but it really works, trust me. The idea has to stand on its own. The good ideas bubble up. Once you've done that, we tend to do another round of sketching. So from the ideas which got the most votes, we'll then expand on one of those. So say, oh, this looks really promising. I'm going to go from one small cell to a more detailed sketch, maybe a storyboard of a flow within that idea, and do voting again. So that takes us through to the next phase, which is deciding. So essentially, you've now generated a bunch of ideas. So maybe you have like 4 or 5 different competing ideas of how you might solve the challenge which you were looking at. This is kind of like the bridging day. How do we get from that range of ideas to what we actually want to build and test? How do we narrow down and decide on it? So we do more voting as well, but sometimes we'll either say there's one clear direction, okay, we're going to build that, but sometimes there's competing ideas. So sometimes we might decide, okay, these 2 ideas both have promise. Perhaps we'll try and prototype both of those and test them against each other and see which one works. Other times, it's really important to be able to break ties. So sometimes you might nominate someone as the decider, someone who has like a super vote. Maybe their dot is worth 2 dots or something. Maybe it's your CEO is in the room and like they have the best product sense. But it's really important to kind of break deadlocks and keep moving rather than get stuck spinning on what should we do, what should we do. At this phase, it's also really interesting to capture the conflicts and the assumptions that your prototypes, your potential solutions have, so you can be really explicit about those. When you have a conflict, it's great. It means that this is a decision you have. This is a lever you can pull in order to get the best outcome. So you might, have a conflict like, should we offer federated log-on versus offering our own log-on or something like that? This is great. So you can then test that in your prototype stage. The outcome of this day is hopefully you've whittled it down to maybe 1 or maybe more than 1 prototype, hopefully just 1. And you want to script a user journey, which is like, this is what we're going to build in the prototype and test. So this is the steps we want to do. It's basically writing the way you're going to perform the testing at the end. So day 4, Thursday, or maybe just the same day, you build a really quick prototype. So the key thing we see here is it's just real enough to get realistic responses from testers. So you're going to put this in front of a real person, a real potential user, and they're going to be able to click through it. So you might use something like Envision or some tool like that, or I'll get back to prototyping in a few minutes. You might make a native Android prototype. You want to be quick enough that you can build it in 1 day. That's quite challenging. But it has to be real enough that you're going to get the real kind of feedback from your users. And the last stage is testing. So this is performing a user study. So you'll invite 5 people. We say 5 people are enough to get to see patterns emerging from data. And after you do 5 interviews, you kind of get diminishing returns. You start to see the same things again. You don't get as much value. So we say 5 is about the sweet spot to come in, and you put them in a room with one person is kind of conducting the interview and sets a task, says, I'd like you to perform X with our prototype. And the rest of you are kind of in a room. We tend to use like a hangout or something like that so you can see what's going on. And so you observe and you kind of sit on your hands and try not to jump up and say, no, you just click that. Because if anyone was done testing, it's kind of crazy. And this is what we do. We literally take notes on Post-it notes again, a lot of Post-it notes, like I say, and we'll have a row for each task that we've asked the user to test the prototype, and a column for each user who's doing it. And in that, we'll capture the things that worked well and also the problems we have to solve. We tend to try and color code things. You might see mark something in red if it was a problem, something in green, and then again, it lets you see these clusters. And that's it. That's 5 days. That is the process of doing a design sprint. At the end of it, hopefully you've understood the problem a lot better. You've generated a whole bunch of potential solutions. You've narrowed down to your most likely or best bet for a winning one, and you've tested it in 5 days. What that should give you, hopefully, is enough data to go off and either build a product, or perhaps you learned something and you might start another sprint based on that learning to refine it or to go in a different direction. So I've tried to kind of stick to the official, I guess, way you run a sprint there. But I wanted to share some insights as to why I think sprints are interesting and why we as developers can use them. One of the things I love about it is it controls for the influences of groups versus individuals. So groups are great at what we call convergent thinking, really, like gaining a consensus, or narrowing down, or weeding out kind of like outside perspectives. So this kind of controls for that by baking into the process when you do things as a group, things like voting happen as a group, versus individual work. So we're much better at being creative. Like studies show that we're much better at being creative individually rather than as a group. So all the sketching, for example, happens on an individual basis rather than as a group sat around a whiteboard trying to say, a little bit to the left, a little bit to the right. By baking into the sprint process when you do things as a group and when you do things as individuals, it kind of controls for all that stuff, and it means you move through it much, much faster. Speaking of moving really fast, that's a benefit in and of itself. Because you move through ideas really, really quickly, you don't fall in love with them. Like, who here has worked on the feature for a week or two, and then it got cut? Like, it kills you, right? Like, because you got attached to it, you got attached to the work, it's really, really hard to see it objectively, whether it's going to work or not. You kind of just are invested. By moving fast, by forcibly the process moving you along for it very quickly, you don't get this attachment, so you can learn from something, discard it, and move on. There's a focus on low fidelity, which is great, which I think is, as well as helping you move fast, it's also a leveler. Like I mentioned before, some people are better at selling their ideas. You've ever seen a designer who presented an idea and it looked beautiful. It was in a high fidelity comp with just the right drop shadows and balance and colors, which might mask the fact that the idea itself isn't great. By working in low fidelity the whole time, the idea has to stand on its own. You can't mask it. You can't cover over it. Focus is on the user. We're intimately familiar with our products, right? We spend days working on them, building them. We know them inside out. Sometimes it can be hard to kind of step outside of that and get the outside perspective of someone just using your product for the first time. So the sprint process, by baking in the testing and the interviews and so on especially, forces you to think from the user's point of view, which is only going to be a good thing. It's kind of like a Trojan horse for getting research into your design technology, design methodology, I think. And the last thing is you always learn something. So say on the last day, you test your prototype and it completely fails. All five of your testers come in and bomb. They can't use your product at all. That's great. That's fantastic. Because think how much time you saved. If you'd built that, if you'd spent a couple of agile sprints actually building that and shipping that, you would have wasted that time and also then have the problem of where do we go from here? By just 5 days might sound like a long time to spend on this design process, but it can actually save you huge amounts of time. So yeah, you'll always learn something. So that was the Google Design Sprint. There's a book that's recently come out on it. You can find it at gv.com/sprint. There's other great materials online. Also, I think GDG, so Google Developer Groups, we've provided a bunch of resources for running sprints to GDG. So if you're interested in trying this, or maybe sitting in a sprint and seeing what it works like, maybe get in touch with your local GDG group and see if they have sprints going on. Right, so my next tip for working with designers is to embrace design systems. So design systems, what I mean by that is, standards in design, which on Android pretty much means material. So Material is great in that it's this kind of common vocabulary. You don't have to like reinvent the wheel all the time. It provides off-the-shelf solutions and patterns and things which bake in, research and good design techniques and so on into them, so you don't have to reinvent them. Hopefully you all agree with that. One thing I hear a lot from developers and designers is they worry about becoming, a same app, like becoming homogeneous. How do I stand out if every app, uses a navigation drawer and cards or whatever it might be? This is a very real kind of concern, but also I don't think it's a limitation of Material. I think Material raises the floor in that hopefully it makes everyone's base level of design better, but it doesn't kind of impose a cap. It doesn't like stop you from going, to great design, is the way I think of it. But I wanted to share with you a way I've been thinking about material design to help you to understand like where you can vary it and how it should and shouldn't constrain you. So if you think about material design as a series of different layers almost, there's a few by just splitting them out into 3 layers, I think it helps you to kind of think about material. So let's just go through them. So the first layer I like to think of is what I call human factors. So some stuff in material design is based on just how humans interact with software. This is things we've learned from cognitive science and research. Things like humans have fingers between 7 and 10 millimeters in diameter generally, which is why we say use touch targets of minimum size 48 dip, right? This is stuff which is observably true. Things like people recognize tangible objects. You know that this computer is separate to this desk because it's a different thing, and that's why we bake it. We say use surfaces and shadows to separate those surfaces to show what's separate to each other. Things like spatial metaphors. We know that people learn spatially and they understand relationship. That this thing is over there and that thing is over there, which is why we use motion to guide user, to help them feel located. So these kind of human factors are things we know to be true. And by thinking about these and separating them out from other things in material, you can see that these things are very unlikely to change. So unless there's a technological breakthrough or an understanding of how people interact with software changes, they won't change. So we would advise you to avoid deviating. Don't go changing these kind of things in material because they're so fundamental. The next layer I like to think about is a layer of conventions. What I mean by that is any software problem, any kind of design problem, there's probably a million different solutions. Like navigation, there's a million different ways you could do navigation, but you shouldn't. Because if you do something completely bespoke, you're basically asking people to learn it from you when they use your application. If you follow a pattern, a common convention, learning in one place helps you in another place. Because your users know how to use, a navigation drawer in the Google Maps app, they'll instantly know how to use it in your app, hopefully, because they've used a floating action button in Gmail to start a new email. They'll recognize, oh, that does an action, that's an action thingy. This kind of shared learning leads to use in other places. The actual patterns that we choose, that we put into material, what we choose to put in is less important, I think, than being consistent everywhere. Because if you start using it inconsistently, that's when you get this weird feeling like, oh, it looked like tabs, but I couldn't swipe between it. What else is wrong? So these conventions, these evolve over time. Hopefully we've selected some really, a good covering of them to put into material. But these things change. New patterns emerge, like bottom navigation, controversial as it is, emerged and was added and recognized to the specs so that when people start using it, it's used consistently across different applications. But patterns, they are patterns. They're not going to cover every single use case. If your use case isn't covered by a pattern, then it's okay to deviate. The material is guidelines. It's not hard and fast rules. So start from the patterns, and if it isn't working, if you have evidence that the pattern isn't working from you, then it's okay to change. And the last layer or group, I guess, is kind of a personality layer. So this is how you express your brands. This is things like typography, color, the tone of your writing style, the way that you use motion. So material is in no way prescriptive here. So we have some suggestions in our guidelines, but this is where you get to come in and vary things, and this is where you get to show your own personality. This is where what's an example? Something like Flipboard, for example, it has a very unique interaction. The way that they use motion conveys their brand. It's not within the spec, for example. It's completely different to that, but this is how they express themselves. Color, for example, even though we have some suggested palettes if you don't have your own branding, Ferrari, for example, isn't going to use material red 500, right? They're going to use their own red. This is how you express yourself, and this is completely up to you. We have some suggestions. It's more like some systems for working with color that work well with the rest of the material, but we don't prescribe anything here. So this layer is up to you. It's likely to evolve to be very different from app to app, and it gives you this large expressive range. So hopefully that kind of model of breaking out material makes you realize when you should follow things. So maybe the patterns, you should start from the patterns first, versus when you're more on your own. And I guess my takeaway from this section is really to deviate with purpose. So start from understanding the pattern. So start from understanding what the rules of the road, the common way of solving this problem are. And if and only if they're not working with you, that's when you deviate. That's when you start pushing the boundaries and seeing where you can take it to have better effects for you. So hopefully that helps you think about material and how it can help you in your development and design work. And the last section I'm going to go through real quick, because I'm running out of time, is on designer and developer communication. I think this is a huge thing. So maybe you do work with a designer, but sometimes that can feel red lines get thrown over the fence and then you're on your own to implement them or something like that. I don't know. I feel like communication is the key to having a better designer-developer kind of workflow. And when this works, then magic happens. So the thing I would like to say here is recognize that you have extremely valuable skills as a developer that you can offer to help improve this subject. And I'm going to just pick up on a couple of them that I think are really, really interesting. The first thing is prototyping. Who here prototypes anything? Not very many hands going up. Maybe I should define what I mean. So prototyping is a very hot topic for designers. There's a bazillion tools getting launched the whole time for designers to prototype the work before it gets built. Especially around motion. I think prototyping is absolutely awesome for a few reasons. Firstly, it gets everyone on the same page. So a bit like we talked about in sprints, you might have an idea for how the product should work. Your colleague might have an idea for how the product should work. But even if you're talking on the same email or whatever, the ideas in your head are going to be slightly different. Getting it out of your head and into a prototype is this common thing. You can then have much more constructive conversations. It's really good for that. It can prove a technical solution. So if you're worried about how something is feasible or is going to work, you can actually prove it. And you can test it in front of real users. So like we saw in the design sprints methodology, they use prototypes to actually test them in front of users and get feedback on an idea. And again, like design sprints, prototypes are quick and disposable, which is kind of the point of it, which means you get to try something, learn from it, move on without being too invested in it. I love this quote from Mike Davidson, which is prototype is worth 1,000 meetings. You can, rather than getting bogged down discussing what you should do, show, oh, do you mean this? And then you can have a much more productive conversation, I think. So hopefully, you agree that prototyping can be useful and has some useful attributes. But why does prototyping have to live in a separate flow? Why do we have to use things like InVision and so on? I personally am a massive fan of native prototyping. So actually building an Android application to test something. So here's an example. This is from a conference app you might recognize, where we were having a discussion about some changes to the navigation flow and so on. And we were going back and forth internally about sketches and how it should work and what it should feel like and so on. And so in the end, I spent 2 hours and just built a prototype and emailed it around and said, this is what I'm thinking, discuss kind of thing. And this got everyone on that same page. Well, let's put those criteria up again. Sending around a native Android app, it got everyone on the same page. It proved a technical solution, so we weren't actually sure how we might implement this. And what's more, it lets you test things closest to Android. So, for example, we were worried about how a certain approach might affect accessibility, and actually building a prototype meant we could then test accessibility, properly, prove it, rather than just worry about building it properly. I put a question mark versus quick and disposable, because this comes down to the skills of the person involved. if you consider design as just your designer's realm, then building an Android prototype isn't going to be considered quick and disposable if they don't have those skills. This is where I think we as developers have an opportunity to help. Like, if you can sit down and pair with a designer, or even just create it yourself, this is showing huge value to them. Like, designers are kind of like, reaching for all these prototyping tools because they don't have the skills necessary to express it in the native format. I think native prototypes are the closest thing to reality of what you're actually going to build. So therefore, in my mind, the most useful. If you can actually put this in front of a user, and there's the minimum number of things they have to just accept and move on from. So, when you put an envision prototype, there's a suspension of disbelief that the highlighting doesn't quite work or whatever it might be that you don't get when you have a native prototype. Also, you don't have to learn a whole new tool or skill set. You don't have to learn Framer or Principle, or your designers don't have to learn a new tool just to then throw that work away and start again. Or when the next hot new tool comes along, have to discard all that time they spent learning it. This is how the product's going to be expressed at the end of the thing, so it's the most useful, I think. Next thing I think that developers can offer designers is the fact that we are often like Android natives, right? Who here has worked on a project where they've had a designer who didn't use Android as their daily driver? Probably a fairly common thing. Wow, not as many hands as I thought. So I've come across this a lot. And so we have an opportunity here to help educate them, and this can really help the process, the flow, because there's, we think these designers are all, knowledgeable or whatever, perhaps. But they often struggle with some basic things like, what size do I make my canvas in Sketch when I do file new project? Like, this is scary to them. Android is scary to them. No designer I've kind of met has understood dips properly. So this is where we have an opportunity. You could let's grab lunch, let's grab a coffee. This is how Android treats it. It's it sounds scary, but it's not a big deal. Start with a Nexus 5, and then we'll vary it from there, and we'll do a tablet. Explain it to them. We know how this stuff works. Assets. Asset production is the bane of designers' lives. We can explain it again and help them with this and make it less scary for them, such that they won't be fearful of designing for Android. This has got so much better lately. We have things like vector drawable compat and the Android Studio's vector rasterization process. Designers don't want to think about, I had to produce MDPI and XXHDPI, and they don't understand what that means. So you can sit down with them and help them with that. Look at the tooling that's popping up. Things like Zeppelin and Simply are going to really, really help your flow of tracking and producing assets. Fragmentation, the F word. Again, Android's scary to designers because if they're not natives, they don't understand that there are a ton of different Android versions out there. But we have technical solutions for it. We have app compat. We have the design support library. We have solutions that we only want one design. We don't want them to think about the proliferation of different patterns, platforms out there. It shouldn't be a scary thing. Explain that to them. This will help them. And the last point I want to make is something I call paper cuts. This is small little problems. Like, who's used an app that you just knew that the person who designed it didn't use Android? So it might be things like, they don't use the share intent, or the tabs don't swipe, or touch feedback isn't quite right, or it didn't have the double tap and drag zoom gesture where appropriate. These little paper cuts add up, and they might not be conscious. A user might not look at the app and say, this is wrong, but it will just feel wrong. So this is places where you can help. So that was just a few quick rapid-fire points where I think we can really help. There's a whole session today, 11 o'clock, on we're all on Team UX about design-developer communication. So I'm going to go to that. I hope you guys do too. But I'm running out of time, so I'm going to wrap it up now. And just say, we are all designers. We're all making product decisions. And more than that, as developers, we have the final say. If a designer designs something, it's just art until the point at which you actually implement it and it becomes real, and it's actually then the design. So we have a huge amount of power and responsibility, and I think the sooner that we embrace that and think of that as an opportunity to kind of make something awesome, the better. So take responsibility, start thinking like a designer, and build awesome apps. So, grazie mille.